All right, so let's look at some modeling with quadratic equations. So in other words, we're looking at some word problems. And specifically, we're looking at word problems where we're interested in finding a max or a min. Quadratic functions work really well for those type of scenarios if something can be modeled that way. So that's what we're going to look at for our word problems. So for t in seconds, the height of a baseball in feet is given both in standard and in vertex form by the following. So here is our standard form right here, and here's our vertex form. So y is equal to f of t, which is equal to negative 16t squared plus 47t plus 3. And then in vertex form, it's negative 16 times the quantity t minus 47 over 32, all squared, plus 2,401 over 64. All right, so we need to find the maximum height reached by the baseball and the time at which that height is achieved. Okay, so that max height is going to be our vertex, and we know that we're going to get a max because we have a negative 16 for a, which means our function is going to, our parabola is going to open down. And that gives us concave down and a max. So our vertex here is 47 over 32, comma 2401 over 64. And I went ahead and put these in my calculator just to simplify them down a little bit so I can make more sense of it. And I got 1.47, comma 37.52. Now, if you think about how you would graph this, you're going to put time on this horizontal axis for your independent variable and height on the vertical axis for your dependent variable. So that means this number here is the time, and the second number is the height. Okay. All right, and so we're going to write a sentence that sums this up, so explaining what this means in context. So the ball reaches a max height of 37.52 feet at t equals 1.47 seconds. Okay, so there we go. Number 9. So a tomato is thrown vertically into the air at time t equals 0. Its height, d of t, in feet above the ground at time t in seconds is given by d of t is equal to negative 16t squared plus 48t. And we are going to be looking for a max over here. So we need to put this into vertex form to make it easier to find this max. All right, so the first thing I want to look at here is the standard form here. This a is equal to negative 16. This a is going to be the same over here. So in our vertex form, this is a times x minus h squared plus k. This a and this a are the same. So I can bring this over here. And then to get this vertex, what I'm going to do is I'm actually going to graph this in Desmos. And then I'm going to find the point for the vertex so I can plug it in here. Okay, there is an algebraic way of doing this called completing the square, but we do not cover that in this class. If you know how to do it, you're certainly welcome to use it. But in the meantime, this trick with Desmos will work really well. Okay, so let me switch screens here. Okay, so you're going to see on the screen I have y is equal to negative 16x squared plus 48x. So I use x because Desmos defaults to x. Ours has a t in there, and that's fine to replace that, to graph that. So here is our function, and here is the vertex. And Desmos is really great about telling you the coordinates of that vertex. So our vertex is at x equals 1.5, and our dependent variable value is 36. All right, so let's come back to our page and work on this a little bit more. Okay, so I'm going to fill this in. This is my h, and this is my k. So I know that this is x minus 1.5 squared plus 36. Okay, so I have that filled in. All right. I would like you to pause the video and definitely do B. You should be able to do that now that you have the vertex. And then for part A, it says find t when d of t is 0. So in other words, when negative 16t squared plus 48t is equal to 0. And you can do this either with factoring or with the quadratic formula. You'll get two values for that. So pause the video, give both of those a try, and then we'll take a look at them together. Okay, so hopefully you gave that a try. Let's see what we can do with this. All right, so let's try this maximum one here first, because this is very much just like this one we did here. So the tomato is going to reach a maximum height of 36. So max height of 36, and we'll put units on there, so feet, at t equals 1.5, and this is in seconds. Okay, so these two are very, very similar. These are very classical problems that you'll be asked to do with a quadratic equation. And then let's look at part A. So we're looking for those zeros, the places where we're going to cross our horizontal axis. If you use the quadratic formula, you would have A is equal to negative 16, and B is equal to 48, and C is 0. So those would be your constants to plug in. If you factor it, I notice that there's a t in both of these, so let me pull a t out. So essentially I'm dividing each term by t. So if I divide negative 16t squared by t, I get rid of one of those t's. If I divide 48t by t, I lose the t altogether. So I get just a 48 is equal to 0. So you have two things being multiplied together, so I can use that zero product property. They either get t is equal to 0, or negative 16t plus 48 is equal to 0, which means t is going to be, I'd subtract that 48 over, then divide by this negative 16, so that gives me 3. So I have t equals 0 and t equals 3 are the two times. And it says, what is happening to the tomato? So here, this is right before you throw the tomato. Right, that would be the start of this whole story. And t equals 3 is when the tomato hits the ground. So we start at 0, it reaches a max height at t equals 1.5, and at t equals 3, tomato hits the ground. Okay. And if you plug these in, you're going to get into the quadratic formula, you would get these same two values as well. Okay, so either way is totally fine to figure that out.